As we depart from the port of Lerwick, a town nestled on the mainland of the Shetland Islands, the cold morning haze wraps around us like a veil, casting a quiet stillness over the water. The early light barely breaks through the mist, and the gentle hum of the ship's engine is the only sound as we cut through the calm sea. In these early moments, as the world slowly begins to wake, this is where the real story begins. This is not just about the technology and equipment, but about the people. The divers, engineers and technicians working in harmony to achieve extraordinary feats. At the core of this mission lies the microhabitat, a groundbreaking innovation designed to transform the future of subsea welding. Combining state-of-the-art technology with steadfast collaboration, DCN is not just tackling the challenges of the North Sea, but also raising the bar for safety, efficiency and achievement in the subsea industry. This is a journey into the depths of the ocean and the future of underwater operations. Based in the Netherlands, DCN Diving has been a pioneering force in subsea operations since 1957. Founded by former Navy diver Wim Vriends Sr., the company began with modest roots, but quickly established itself as a world leader in underwater engineering. As a family-run company, DCN has maintained a strong commitment to innovation, safety and excellence, while fostering a close-knit team culture that has been passed down through generations. From their involvement in the historic construction of the Oosterscheldekring flood barrier to their global impact in offshore and inshore markets, DCN has remained at the forefront of subsea innovation. Today, DCN is recognised for its expertise in hyperbaric welding, underwater concreting and subsea rehabilitation, driven by a commitment to safety, quality and technical excellence. This project takes DCN to the unforgiving waters of the North Sea, where a critical repair needs to be carried out on an ageing offshore platform. It's not just one project, but two major operations running in parallel at a depth of 76 metres. The ROV department is not only assisting the divers with the delicate subsea welding, but is also tasked with the removal of 140 depleted anodes from the conductors. Using a state-of-the-art dive support vessel as their work platform, the crew is equipped with the most advanced tools available, including the revolutionary microhabitat to complete the complex welding. DCN's expertise is being put to the ultimate test, showcasing their versatility and precision in these challenging conditions, and underlining their ability to tackle multiple operations with seamless efficiency.
The current project that we're working on is northeast of Shetland in the North Sea in the UK continental shelf. There's two fatigue cracks on an oil and gas jacket. One of the cracks is approximately 350 millimeters long, and then the other crack is more significant, little over a meter.
It's quite an innovative project. The guys have come up with some really clever ideas on how to repair welds on platforms, or jackets as we call them. So we are working on a particularly old platform, put in the late 70s sometime. The technology used back in the day probably wasn't quite as good as it is today. Obviously with wear and tear in the North Sea, quite a hostile environment when it comes to weather and the elements. And so it's taken a beating over the years. And despite all the sort of IRM or inspection, repair and maintenance schedules that are carried out over the years, you still end up with things that need repairing.
So in this particular project, it was fast-tracked. Working in the North Sea, you've only got a, say a 6 or 7 month operating window, and where the weather in the winter becomes unworkable. We had less than 2 months to prepare. I started off in the industry at 18, and then actually I got into hyperbaric welding quite by accident. I was working in a project in the Black Sea where one of the pipelines we were laying became damaged, and the only way to repair it was in situ using hyperbaric welding. And I just thought it was the most incredible thing to weld something subsea under pressure. Basically the rest is history.
In the world of subsea engineering, DCN holds a significant advantage. As the only diving contractor with its own hyperbaric test centre based in the Netherlands, DCN has the unique capability to develop, test and qualify hyperbaric welding procedures entirely in-house. This is a rare asset in the industry, allowing DCN to simulate the exact conditions divers will face offshore, welding under pressure to mirror the harsh subsea environments. By controlling every stage of the testing process, DCN ensures its procedures meet the highest international codes and standards, offering unmatched precision, safety and reliability, allowing DCN to be fully prepared long before operations begin at sea. Before heading offshore, rigorous preparation and training are crucial. Here at DCN's in-house hyperbaric and wet test facility, divers, engineers and technicians undergo extensive training to ensure they are ready for the challenges of the open sea. This state-of-the-art centre allows them to simulate real-world conditions, test procedures and refine their skills, making sure that when they hit the water, they're fully prepared for any situation. After obtaining the crucial welding procedure qualification, the divers must also earn their individual welder qualifications, demonstrating their ability to perform in the exact conditions they will face offshore. With DCN's unparalleled hyperbaric facility, they can perfect their skills under pressure, ensuring that each diver is not only skilled, but also fully certified to carry out hyperbaric welding in some of the toughest environments on the planet. Hyperbaric welding has been a key tool in subsea repairs for decades. Traditionally, large, cumbersome habitats, sometimes the size of small buildings, were lowered to the seabed to enclose the area that needed repair. However, there are certain instances that large habitats are required, i.e. pipeline tie-ins in the case of structural member severances. These habitats created a dry environment for the welders to work in, isolating the section of the structure from the surrounding water. While this method allowed for precise welding at great depths, it required extensive planning, a large crew and heavy equipment to put in place. Operations could take days to set up and execute, using significant manpower and resources. Additionally, the sheer size and complexity of these habitats meant that every project came with logistical challenges, making them costly and time-consuming.
Repairs on severed members can be a very expensive and very challenging undertaking. A lot of procedures or systems we used to use under the water have kind of been taken out of the systems. Things like broco burning, so oxy-arc cutting underwater. It was a very hazardous task to undertake.
So conventionally, a habitat would be the size of a large shipping container on the seabed, and the diver would have all his diving gear off and he'd be dressed just as I am now in welding apparatus.
The micro-habitat now, compared to the old habitats, was a big massive habitat over the top of the member with guys inside it. I mean, I was on bar protected 20, 30 years ago and the habitat was the size of that back deck. It was huge, sitting over a pipeline.
When you compare the microhabitat to conventional or bespoke habitats, the cost savings is huge. And that's due primarily to the size and the speed at which we can execute a project offshore. You're looking at weeks, whereas opposed to months for a conventional or bespoke habitat.
It goes right over the defect rather than going right over the whole member. So yeah, it's a lot quicker, a lot smaller, a lot more efficient, and it's easier to install than those big ones. And the personnel involved is a lot smaller than those massive ones from years ago. Now, 30, 40 guys on the back deck.
But out of these challenges came the inspiration for something new, the microhabitat. DCN saw a need for a simpler, more efficient tool, and thus, the microhabitat was born. This smaller modular system has transformed subsea welding, allowing for quicker deployment and reduced risk.
The development of the microhabitat came by chance. We were requested by an offshore major to look into underwater wet welding as a possible solution for repairing underwater jackets. It was clear that basically all you needed was a dry environment, the ability to grind, good vision, and ability to preheat, and that could be shrunk down into a much smaller enclosure.
The microhabitat is a genius of an idea over conventional methods of what they used to use. It's very easy to mobilize it, get it to the job, and for the divers to work inside comfortably.
The introduction of the habitat changed the whole industry because it makes the task so much easier and safer for the diver.
I think there were a lot of people that really quite gobsmacked as well. It's so simple, how could it possibly work, you know? And it really is, it is that simple, and it does work.
The microhabitat's innovative plug-and-play design and modular structure allow it to adapt to different repair tasks, making it versatile and efficient. Unlike traditional habitats, it focuses only on the area that needs attention, saving time, resources, and reducing the overall risk. For the team on board, the technology is invaluable, providing a streamlined approach that helps them overcome obstacles and complete vital tasks with greater efficiency, even in the face of challenging conditions.
The microhabitat essentially is a modular system and it's quite adaptable. We have different habitats for different diameters.
One of my favorite things of the microhabitat is that it is all plug and play. We can take the cameras, lights from habitat 3, plug them into 6. The glove ring covers, everything is interchangeable.
Quite often we're faced with, when we come out and we excavate the defect, it's actually in a different location than reported. So we have to adapt the existing microhabitat to repair the given location.
Depending on where the repair is, they either design a new habitat built from scratch or else use one of the other habitats that have been proven.
The guys that are involved, whose baby this is, we've got some of those guys on board. They are just constantly solving problems and improving systems and making modifications to the habitats and the processes and procedures, and it's just getting better and better and better. It's only going to go forward from here, and I honestly believe that it's a super solution. It really is.
At DCN, safety isn't just a priority, it's the foundation of every operation. The offshore environment is unpredictable, and DCN follows strict protocols and procedures to ensure the safety of every diver, technician and crew member. It's all about processes and procedures that leave no room for error, where every task is meticulously planned and executed. DCN's commitment to safety is backed by their impressive safety record statistics. From rigorous training and equipment checks to carefully coordinated operations, DCN leaves nothing to chance, making sure everyone returns safely from each mission.
Safety and environmental regulations, they're pretty much the Bible we work by these days. Everything is about safety. It's one of the better changes over the years in the industry that we focus more on welfare, safety, and that type of thing.
Definitely, there's a lot of protocols in place. We'll do a safety drill when we go in with a new team, so I will do a mock safety drill.
When dealing with the habitat, there's a lot of safety precautions to be taken, especially with the high pressure gas. We've got 110 going through the umbilical down to the divers so they can use the grinders and the habitat and stuff. So we have to barrier off the deck, make sure no one's around the hydraulics and the reel when we are overboarding the umbilical.
You have a whole support system, that's here just for you underwater. So they're the number one guys waiting and watching you to make sure that everything's going to be okay.
If we can mitigate against the diver doing something, then that's the ultimate goal offshore, really. There's certain tasks that the divers are a lot better and the ROVs physically can't do. And there's other tasks that we can do quicker, faster than the divers, and it really is, if the divers don't have to do it, then that mitigates against what we need for safety.
While divers perform the delicate and skilled tasks underwater, ROVs step in where it's too dangerous or simply impossible for humans to go. These remotely operated vehicles serve as an essential lifeline, acting as the eyes and hands of the crew in the most challenging environments. Whether it's monitoring the progress of a repair, inspecting hard-to-reach areas, or ensuring that everything is running as safely as possible, ROVs play a crucial role in supporting the divers and the operation as a whole. Without them, many of these intricate jobs would be far more difficult, if not impossible, to carry out with the same level of precision and safety.
So the ROV department are on board to assist in the diving operations, primarily for diver safety and to observe the divers in the water.
ROVs are a massive help on this project, or any project in fact, when divers are involved. They're constantly like Big Brother watching over our shoulder, making sure we're doing things safely and effectively. They can also shed light, literally shed light on some of our jobs whenever our hat lights aren't bright enough. So they are a fantastic friend to have.
At the end of the day, we've got a vessel here, a dive support vessel, with a POB or up to 140 people on board. But there's only 2 people subsea doing the work. Having that additional ROV or multiple ROVs in the water, it can dramatically increase productivity.
The ROV is critical to all subsea operations nowadays. In my view, you're not safe doing anything underwater unless you've got an ROV there watching and assisting one way or another. Because it's not just the overall eyes, it's there to assist the diver if necessary too. We mitigate against that by giving overall views for the dive supervisor. The picture on the diver's hat is very close up on both the divers. It's very hard for them to see the overall view of what's going on. We mitigate against that purely with providing that view.
At the heart of every successful operation is a tight-knit team of skilled professionals, each bringing their unique expertise to the table. Whether it's the divers plunging into the depths, the engineers solving complex challenges, or the ROV operators providing a steady hand, the crew operates as one cohesive unit. Their years of experience, combined with an unwavering commitment to the job, form the backbone of DCN's success. It's their teamwork, precision and sheer dedication that ensure each project is executed flawlessly, even in the most demanding conditions.
My name is Barry Dempsey. I'm currently acting as a hyperbaric welding coordinator within DCN.
So the primary responsibilities for the Habitat Tech is to make sure that everything stays working and is ready to go.
What I do is I get involved with every task actually. As an ROV manager within this vessel, there's so much to it.
I'll be in this weld control, monitoring divers on the seabed or at depth, performing inspection and welding operations.
My primary role would be to get them down there, get them on the job as quickly and as safely as possible, try and keep everything moving and get them back on time and bring them back safely.
The selection of the crew is, I think, something that's incredibly important. You need people that are obviously competent, but then they're willing to go that extra mile. I think that's the type of team that we have here.
DCN is committed to ensuring the future of subsea engineering by investing in the next generation of engineers. Ewan and Paul, two promising young interns, are a testament to this commitment. Ewan, with a background in mechanical engineering, and Paul, fresh from his studies in subsea technology, are both gaining hands-on experience under the guidance of seasoned professionals. Through DCN's robust training programs and state-of-the-art in-house facilities, they are learning not just the technical skills, but the critical thinking and adaptability needed in the field. DCN's goal is to pass on decades of expertise, ensuring that Ewan, Paul, and their peers are well prepared to become the future leaders of the industry, ready to tackle the challenges of tomorrow. What sets DCN apart from larger companies is the personal attention and hands-on experience that young engineers and interns receive. As a family-run company with decades of experience, DCN offers a unique working environment where everyone's contributions are recognised and there's room to grow. Unlike the more impersonal nature of larger organisations, DCN takes pride in mentoring young talent. From day one, new recruits are immersed in real-world engineering challenges, not just shadowing experienced workers, but actively participating in the work. DCN's in-house training programs and hyperbaric test centre allow young engineers to get direct experience in the procedures and technologies used offshore, providing them with invaluable skills that go beyond the classroom. For those looking to start a career in subsea engineering, DCN offers unparalleled opportunities, whether it's working with advanced tools like the microhabitat or collaborating with a tight-knit team of experts. DCN provides young engineers with the chance to push the boundaries of what's possible in the industry.
My name is Ewan. I'm an engineering intern.
My name's Paul and I'm an intern engineer at DCN Diving.
This internship has really pushed me. They demand quite a bit from me, but the rewards are unparalleled. You know, the experience I've gained through this internship is second to none.
One of the most important learning experiences I've had working on this internship has been during the offshore campaign. You realise how critical it is to be alert on shift.
What we're seeing in industry these days is near impossible to find good people. The only thing left to do, if you can't find people that are available in the market, you have to train them. And that's something that DCN has taken on board. In the UK, we introduced the Young Engineers program. And in the last 3 years, we've already developed 4 young engineers. And it's something that we pride ourselves on. You've got to give back, and you've got to encourage these young men and women to pursue their dreams and become all they can become.
Personally, I think it's crucial for any engineering student to do an internship like I've done with DCN. I think it's really the only way that you can actually bridge the gap between what you learn at uni and what engineers actually do in the field.
After gaining all this experience, not just offshore but onshore, working on the procedures, the high-res, all the risk assessments, that experience as a whole will put me in good stead for any future jobs or projects with other companies or here at DCN.
As the industry continues to evolve, so does DCN. With tools like the microhabitat leading the way, the future of subsea engineering looks brighter than ever. Innovations in technology, coupled with the company's wealth of experience, promise a future that is safer, more efficient, and constantly pushing the boundaries of what's possible.
Already on this project, there have been massive advancements in underwater welding. Last week, we were performing wet welding at 77 meters deep, which was unheard of in the North Sea in the last 3 to 4 decades.
Ultimately, we've developed a good product that addresses a certain need. However, myself and DCN, we're not the type of company to rest on our laurels. We want to keep with the development and keep pushing the limits. And I think one of the first things that I'm keen to try is changing the welding process inside the mag habitat and use a more productive flux core arc welding, or GMAW, which is gas metal arc welding. So it's a wire-fed process, and it's much more productive than conventional stick welding.
At the heart of every mission is the passion of the people who make it happen. The crew on board isn't just here for the job, they love what they do. Their commitment and pride in their work drive the success of these operations. But DCN is far more than just diver welders. Operating across a vast array of subsea operations globally, DCN takes on a diverse range of projects, from hyperbaric welding and subsea construction to underwater concreting, hydropower dam rehabilitation and pipeline installation support. Their work spans civil engineering, offshore energy and underwater inspections, providing innovative solutions to the most complex underwater challenges. DCN's expertise and versatility allows them to push the boundaries of what's possible beneath the surface, offering their clients unmatched precision and efficiency across a wide variety of subsea operations around the world.